I change my mind about this probably every 30 seconds. If you were to ask me, as I've been studying nutrition, I'll probably change my mind about this again every 30 seconds. It's interesting to ask seed oil experts which is worse, vegetable oil or carbohydrate. I go around and travel to low carb Denver. And when I asked Dr. Chris Kenobi and when I ask, Tucker Goodrich and all of your mutual friends who study seed oils, I always ask them, why am I traveling to low carb Denver and not low seed oil Denver? What is worse, carbohydrates and sugar or seed oils?
Well, it's definitely the vegetable oils, vegetable seed oils. And I didn't know that when I first wrote Deep Nutrition. So the first edition of Deep Nutrition came out in 2009, and I gave sugar and vegetable oil kind of like equal weight. People were asking me the same question, like, which is worse? And I'm like, I think they're both really bad. But then as I learned more and I, kept digging into, I kept asking myself questions, what is causing disease? What is the root cause of obesity? What is the root cause of these inflammatory disorders? And I kept finding oxidative stress as the root cause. And that's a chemical term for a type of pathology that damages cells and kills them. And it's found in evidence for oxidative stress being a causative agent of disease is found across every disease that has been studied. When pathologists, study tissues of people who had any sort of dementia, Alzheimer's, Parkinson's, you name it, multiple sclerosis, it's not dementia, but other neurologic disorders, they see evidence of oxidative stress. They see basically oxidized proteins, oxidized fats, oxidized just junk in the cell. And so there's just continually more and more evidence that oxidative stress is really the root cause of more diseases and oxidative stress is driven by vegetable oil, whereas the sugar toxicity is called glycation. And oxidative stress drives glycation, but glycation is not involved in quite as many disorders. And sugar consumption will spike your blood sugar temporarily and cause glycation. That's why sugar's bad. So I think maybe we should talk about that a little bit, like talk about oxidative stress versus glycation. Because
Love
that's
it.
really the battle. That's the battle,
Yeah,
right? Like which
I love
one's
it.
worse?
Yeah, I love it. And I just did a seminar all about cholesterol. And we talked about the things that damage the epithelial lining as an example. But let's talk about the difference between glycation and oxidation, how those are different, and how seed oils and vegetable oils drive that process.
Yeah, so sugar is sticky. And when you feel the tackiness of something like jelly or dried juices or something, you feel the tackiness of something that's sugary on your skin, you're actually feeling those bonds breaking. So the glycation is a bond that has formed between a sugar molecule and an amino acid. Amino acids are the building blocks of proteins. That's what your skin is made out of. So you're actually, that tackiness is those little bonds breaking. And so you can feel glycation, which I think is really cool. So that's just a high level, what is glycation? Now, why is it bad? Well, your joints, for example, need to be very lubricated, right? But sugar is sticky. It's kind of the opposite of lubrication. So I've described it as kind of like a rusting process for your connective tissues. It's unlike a bicycle chain, which kind of when it's rusted, you got to, throw it out. Well, our body's tissues, they can clean up some of that damaged area. They have like what's called RAGE receptors for receptors for advanced glycation end products on the surface of the cell. They can actually clean up areas of the cell that have been harmed by sugar. So like people have told me that they have a lot of candy or sugar or anything that spikes their blood sugar. The next day, they often wake up where they feel it in their fingers or their knees or their ankles, their joints, and it lasts for a couple of days. Well, it doesn't last forever because the body can repair that stuff. So that's like one example of what glycation does. And what is it? Now let's talk about oxidative stress. So oxidative stress is also damages cell membranes and damages our cells. But we don't feel it so much as like a stickiness. What we feel is inflammation when our bodies are undergoing an acute episode of oxidative stress. That'll happen anytime. It can happen in normal life, right? Oxidative stress is part of normal life, but we have to be able to control it. And when you look at the time frame that these reactions occur of glycation from sugar or oxidative stress from, a diet that promotes oxidative stress, mostly rich in vegetable oils, oxidative stress destroys large bunches of molecules. It can destroy like 1 billion molecules per second. And each one of those damaged and destroyed molecules has the potential to become a catalyst for another destructive reaction. So it's basically like an explosion, a miniature explosion. So just on the time scale alone, oxidative stress is more of a threat to our health because glycation occurs over periods of seconds to minutes to hours. An interesting little fact about glycation. I mean, glycation occurs in food too, right? Did you know that?
Yeah, absolutely.
So it's a browning reaction, and we call it
Yep.
the Maillard
Reaction. Yep.
right? So things get brown. So the same thing happens in our collagen. You can take collagen from a newborn and it'll be pearly white. You can take collagen from a 90-year-old and it'll look like toast. It'll be the color of toast. But it takes decades, right? It takes decades. But oxidative stress can destroy tissues in much, much quicker time frame. The whole purpose of an inflammatory reaction, oxidative stress triggers inflammatory reactions, and it has to be quick because when we puncture, when we puncture an artery or capillary, we got to clot that blood really quick so we don't bleed to death, right? So oxidative stress is on a fast time scale, and our body capitalizes on that when it drives inflammation reactions on purpose to solve the problem. And it's just, it can change the way your body looks in a matter of minutes. If you sprain your ankle and it swells up the size of a grapefruit, that's oxidative stress driving an inflammatory reaction. You just don't see glycation doing stuff that quickly. So that's why, that's just one reason why I think it's worse. There's several others.
Yeah, it's such a good explanation. I really appreciate that level of detail there. And maybe you do such a good job of this in the book as well, where you actually talk about vegetable oil. Sounds pretty benign, must come from vegetables, right? It's got to come from celery or carrots or something. Not one drop of vegetable oil ever comes from vegetables, just to be clear. And you kind of talk about the process of how oil is even made, and the reason why it would not be possible to extract this type of oil without industrialization. You go through the process and describe what happens to make vegetable oil, and we'll tag this in the notes. It's the most tagged video we ever tag on the show, the How It's Made episode of canola oil, where they show you this sludgy, gross, nasty crap that they have to bleach and heat and treat with all the chemicals, and you get this nice little golden bottle of canola oil. It's absolutely disgusting. Can you tell us kind of describe the process of how vegetable oil is actually made?
Yeah, so the seeds, the 8 vegetable seeds that I've identified as the hateful 8, to clarify that there's 8 of them, and it's not all vegetable seeds or all vegetable oils, right? So maybe I should just list those out.
Yeah, please.
Yeah, so there's 3 C's: corn, canola, cottonseed. 3 S's: soy, sunflower, safflower. Memorize those 6 because those are the ones that you're going to see in grocery stores on ingredients. And then there's 2 more that are mostly in restaurants. That is grapeseed and rice bran. And all of those seeds were never really bred to be a source of oil, with the one exception of sunflower. And we can talk about that later if you have questions. But what I'm going to tell you about the processing applies to all 8 of them. And so what happens is that in order to get oil out of these seeds at the scale and with the cheap costs that industry demands, you gotta be efficient. And to extract the oil from soybean with any kind of efficiency, you have to use intense heat, like 400, 600 degrees, lots of pressure, very often a solvent called hexane. So the crude oil that you get is disgusting. It's considered inedible and it reeks. That's why one of the processing steps is called deodorization. It's also full of waxes and gums and inedible things. So it has to be dewaxed and degummed. It's also got toxins in there, and those toxins are removed by bleaching and a bunch of other, different processes. So many processes, that's entire factories, multiple sets of factories in sequence are required to clean up the crude soy oil or the crude canola oil, or even the crude sunflower oil. It's a filthy, disgusting industrial waste kind of a product. Literally, it's inedible, and this is the scientists themselves, they call it inedible. Now, there's nothing else in the food supply like that. We don't say that about olive oil. Olive oil is edible immediately, right? That's what virgin olive oil is. It's unrefined. It's the crude oil. It's just gently pressed, and the oil it's so oily, and the olive oil chemical compounds, the fatty acids are stable so that they don't oxidize once they're exposed to the air. But that's not true with the seed oils. Not only do they need all this heat and pressure, and then this refining, the refining strips away the antioxidants that protected the fragile fatty acids, which are called polyunsaturated fatty acids, exposes them to oxygen, and then those will oxidize. And that oxidation takes place forever. Like, it takes place starting in the factory, so that when you buy a bottle of canola oil, it's already got some oxidized fatty acids in there. And then the oxidation just keeps continuing. When the light hits these polyunsaturates, they will oxidize. And when you cook with it, the polyunsaturates will oxidize some more. So the bottles start with a small amount of toxicity, somewhere between 0.6 and 5.2%. So that's it's a lot. It's not parts per billion here, like other toxins in our food supply. Glyphosate, that's parts per billion or parts per trillion, even in some foods. This is parts per 100. So it's 1,000,000 times more significant. And then it just gets worse because there's oxygen everywhere, right? So it's a whole different thing than anything else we've ever consumed. And what you want to look for is oils that just don't need refining. And so you want to look for a virgin oil, or the term is often unrefined.